Lesson 33, Hypothesis Testing Procedure for One Population Mean. Example 2. A physical education instructor stated in class that the mean heart rate for a person at rest is 70 beats per minute. Use the following sample results to test the validity of the instructor's statement at the 5% level of significance. Well, in this example, we're going to test the validity of the instructor's statement at the 5% level of significance. Thus, we'll be conducting a hypothesis test procedure using alpha equal 0.05. Now, the instructor stated that the mean heart rate for a person at rest is 70 beats per minute. This can be expressed statistically by saying the mean heart rate, which is mu, for a person at rest, which is just one population, is 70 beats per minute. That is, equals 70. So we can express this as mu equals 70. A random sample of 24 people were taken to a room where they sat in chairs and watched a 10-minute instructional video on relaxation techniques. After the video, the people were asked to find their pulse and count the number of heartbeats during a 15-second period. The resulting count was multiplied by 4 to determine the number of beats per minute. Here we're told that we have a random sample of 24 people, thus giving us the sample size n equals 24. The collected heart rate data displayed an approximate bell-shaped distribution with a mean of 68.17 beats per minute and a standard deviation of 10.32 beats per minute. Here, we're given that the mean of this sample was 68.17 beats per minute, thus giving us the x bar equal to 68.17. We're also told that the standard deviation was 10.32 beats per minute, thus giving us the sample standard deviation, S sub x, equal to 10.32. Now, when we're told that the collected heart rate data displayed an approximate bell-shaped distribution, this is important because even though the sample size of n equals 24 is not sufficiently large, since the distribution of the population from which the sample was selected reasonably follows a normal or bell-shaped distribution, the hypothesis testing procedure, which relies on the results of the central limit theorem, can be applied. So we'll be conducting a hypothesis testing procedure for one population mean. Thus, the following steps will be followed to conduct the hypothesis testing procedure, starting with stating the hypotheses statistically. Here, the statement of the PE instructor was that mu equals 70. That is, the mean heart rate for a person at rest is 70 beats per minute. Now, either this statement is valid and mu equals 70, or the statement is not valid and mu does not equal 70. To state the hypotheses statistically, we need to label them as HO and H1. HO is always labeled with the condition that includes the equality, and the H1 is always labeled with the one that does not include the condition of equality. So in this case, we're conducting the test of HO, that mu equals 70. Thus, if HO is valid, the instructor's statement is valid, versus the H1, that mu does not equal to 70. And if H1 is valid, the conclusion is the instructor's statement is not valid. Next, we then specify alpha, the level of significance. Here we're using the customary alpha equals 0.05. Next, t-test is the command on the TI-84 calculator that we'll use to calculate the p-value needed to reach the decision. But in order to calculate the p-value, we need the results of the samples. In this case, we're told that the sample statistics were x bar equals 68.17, S sub x equals 10.32, and n equals the 24. So on the TI-84 calculator, we would press stat, arrow over to tests, arrow down to t-test, press enter. Since we have the sample statistics, we need to arrow the input cursor over to stats and press enter to select stats. Down arrow. mu0 is the actual numerical value that shows up in the hypothesis. In this case, it's the 70 beats per minute. Enter. X bar equals the 68.17 beats per minute. Enter. The sample standard deviation, S sub x, equals the 10.32 beats per minute. Enter. N, the sample size, equals 24. Enter. Now the inequality in H1 is a not equal. So with the cursor blinking on not equal, we press enter to select, and then down arrow to calculate. Press enter. The t-test command will calculate the p-value we need, in addition to other results. But all we need is the one that says p equals for our p-value. Since p-values are probability, we'll round them off to the nearest thousandth. So in this case, the p-value rounds to 0.394. Now that we have our calculated p-value, we can reach our decision. Since the p-value of 0.394 is not 0.05 or less, the decision is to not reject HO. And if we do not reject HO, we're saying that the data says that HO could be true. In this case, mu could equal 70. And if mu equals 70, that's the statement that the PE teacher said, then I guess our conclusion is the instructor's statement is valid, since mu could equal 70. So, based on the results of our hypothesis test procedure, we can reach the following conclusion. Therefore, the physical education instructor's statement that the mean heart rate for a person at rest is 70 beats per minute is valid at the 5% level of significance. Notice saying that this statement is valid is different from saying this statement is true. Since we didn't do a census and calculate the mean heart rate for the entire population, we don't really know with 100% accuracy if it's true or not. But according to the sample results we do have, it was consistent with the idea that mu equals 70, thus making the physical education instructor's statement a valid one.